All right. Thank you so much. Yeah, much appreciated. All right. So, as I'm Chad Stewart, as already been introduced. I was like on a really amazing intro again. I was really surprised. But either way, this is navigating front-end complexity, a blueprint for loosely coupled systems. As already introduced, I'm Chad Stewart. I'm a software engineer from Kingston, Jamaica. Been doing front-end engineering for several years now, working in like enterprise, startups, open source projects, both here in Jamaica, and internationally, primarily in the United States. Um, Also, the founder of Tech is Hiring, really was really big in the pandemic. If you saw a goofy guy running around asking if people wanted to retweet their tweets with the hashtag Tech is Hiring, that goofy person was me. Or Andrew Haskell, who's a Golang engineer, who helps run Boston Golang. We both were asking people to retweet things with the Tech is Hiring hashtag. And pretty much what we do is promote jobs, job seekers, and job resources just to help people with their job search in tech. So front-end complexity growth is really sneaky. It's really, really easy to build an application. And if you're not necessarily thinking about how you're putting together your components and just the general design of your application, it really can quickly go from, you're able to build things fairly easily to just like development just grinds to a halt. Anytime you make changes, everything else breaks and you're just like chasing bugs all day, and eventually it just make you look like this very upset cat that I laugh at every time I see him. This cat is so mad. Anyhow, so what options do we have to deal with front-end complexity so that we avoid, the eye twitching of that cat? I'm sorry, I love that cat. But yeah, what options do we have to deal with front-end complexity? So mainly we're trying to encourage a loosely coupled architecture, like the new what it does, it helps you manage your complexity, and more it puts you in a position to be able to make changes that make it more frictionless to make those changes, right? And so we're gonna try and do that. We're gonna talk about some things that will help us do that with our front end applications, which is like atomic design, functional atomic CSS, separating presentation and business logic, and isolated testing, and how these things will contribute to making a more modular application. So atomic design is a component-driven design framework, originally coined by Brad Frost in 2012. He gave a talk on the topic. And before I go into it, I want to talk a little bit about component-driven design, which is the idea of viewing your what you call it, viewing your UIs as a collection of components and building out those components first, as opposed to thinking about the page first and then kind of building downwards, right? So yeah, and atomic design specifically is the relationship between those components as in terms of atoms, molecules, and organisms. And so this is the Tech is Hiring job search resource app. We actually released this recently, but using this as an example. So as you can see here, we have just some typography and buttons. These are considered atoms. So atoms are like the base of of your applications, right? They generally don't rely on anything else, and you use them to help make up the other layers of an atomic design pattern, right? And again, yeah, so it's like the basis, the base stuff. So like I said, typography, this is a header, this is just regular text. I personally consider a button an atom. You don't have to consider this a button an atom. Most people consider it a molecule, but it's about being consistent about these things. And then of course you have like the icons, another header, and then this is similar to the header for the page. And then a molecule is a collection of atoms. So again, the header and then the standard text is kind of put together in this molecule, and then we have this icon and the header to kind of be put together for this category section. And so I also kind of want to quickly point out is like the button is not a part of any of these because but atoms and molecules make up organisms. And so this was an atom. This was just kind of on its own, but it's now a part of this organism, which is the header component, right? And the most important thing here is, give me a second. I'm a little bit, yeah. So the thing here is like the organisms actually, as you go up in levels, the use cases become much more specific. So as you can see here, this is specifically the header for the page, and then this would be just the collection of job search resources. There are two other things. We're not going to talk too much about them right now. Templates and pages. That's kind of where the analogy kind of ends. But templates are pretty much, I tend to use them for creating layouts, but they are pages without without specific data on them, and then pages are templates with data on them. So you can consider this effectively a page. So why does any of this matter? Like, why should we even remotely care about any of this? So I'll explain that with a quick story. So I was able to build an onboarding flow for a company twice, for two different applications for the same organization. And so the first time I built that onboarding flow, and it took a couple of weeks. There was and a good portion of that was kind of learning the code base, learning what knobs I should turn, what knobs I shouldn't turn, and a lot of it was just kind of trial and error and just making sure I didn't break anything as I was putting together the new onboarding flow. And then eventually built a greenfield project for the same organization, and we decided to leverage atomic design for that project. And I remember specifically it was a Friday afternoon. Sat down in front of this machine, and I was just like, okay, the last time that I did this is going to take me. It took me a while, so let me at least get started on this today. And by next week, I'll be in a really good spot to finish, right? So sat down and started working. And 4 hours later, like I remember kind of looking at the mock and then looking at the page, getting ready to just kind of do some other stuff. And I was like, wait, why does the page look like the mock all of a sudden? And it was really amazing to me. So like I say 6 hours because you take some time to have to do code review and things like that, get people's feedback. But for the most part, it was just like this. It was just like a smooth flowing river. Like I have very little issues. Like that's the reason why, like I was pretty much in a flow state. For the most part, that's the main reason why, like it was so surprising to me when it was finished, right? So why was development this easy? Well, partially because a lot of the components were built out already. Like atomic design encourages reusability. So obviously you're building like your atoms and molecules to be fairly reusable, but also it's kind of the plug and play aspect of your components, right? So it's almost like kind of putting Legos into place. Maybe you have some customization, like maybe you change the styling or you apply styling depending on what you're using. You apply new styling to the components. But for the most part, if you're fairly confident in the way the components are built, you just put them into place and then you just kind of move on. It just makes development really quick, really easy, really painless, right? At least for your presentation logic. And this wasn't an isolated incident, right? Like I wasn't the only one that this had happened to. We had actually brought on somebody to help us continue delivery. And generally, when you bring on somebody new, what ends up happening is that you have to onboard them onto the project, and you lose a fair amount of time in the onboarding that you were hoping to save by having more than one person working on the application. The thing is, in this case, that the onboarding wasn't that long. Obviously, I had to explain to him what atomic design was. I would explain to them what atomic design was, and then explain to them the project for a bit. But for the most part, they were able to onboard fairly quickly and add value fairly quickly. And a big portion of that is because the places where they needed to add value, they really only needed to know the thing that they were affecting, right? I get, much like my situation, they had a suite of components they could already leverage, and they just leverage them however they can. And more importantly, because the code base was so modular, at least the presentation logic was so modular, they didn't need to understand the entirety of the code base to add value. Like if you remember the previous story, I had to really know what knobs I needed to turn and what I should avoid to be able to add value without breaking other things. In this case, it's you don't have to, they didn't have to think about that nearly as much. And so we move on to functional atomic CSS. And there are various paradigms that kind of encourage smaller predefined CSS classes, where the classes themselves tend to be labeled as actions. So if you imagine traditional CSS, you have your markup, and then you tag your markup with an ID or a class, and then you define your styles, generally in a style sheet, in another file, and then you have to use selectors to select your markup with the ID or the class, and then you add styles to your application, to the components. A bit of dry mouth there. So yeah. In functional CSS, and this example is specifically through Tailwind, in functional CSS, you apply class names that are predefined directly to your classes. So here's an example, font bold. The action is obviously, I want this font bolded. And then we have another action here, text 6XL, which is we want to make the text large. And 6XL is how Tailwind does like their sizing. It's one of their sizing options, right? And so you apply these classes directly to your markup. Again, why does this matter? Why should we care? Right? So it's significantly easier to reason about the CSS. So again, in traditionally, when we're applying CSS, we apply CSS separately from our components. Whereas in this case, the component, you apply the CSS directly to the component by using named classes, right? So one, the component no longer owns the CSS. So it's the component no longer owns the CSS. You're just applying a suite of predefined CSS classes to the component, right? And so if, say, for instance, you want to change, you don't want the font to be bold anymore, you just delete it, but you delete it from the component right here, as opposed to messing with a style sheet. And so that disconnect between how you think about CSS and how you think about your HTML is a lot easier it's easier to reason about. Errors, because of that as well, errors tend to be isolated to the components that the error is at, right? So here, and in this example here, I did not purposefully add a CSS error, wink wink, nudge nudge, like I did not do this on purpose at all. But yeah, I didn't do this on purpose. And like this error is being caused by BG red, which I have highlighted here. But this component, like these are the same component, or they have the same definition. Obviously, they have different data, but they're the same component. They're being mapped out. And if I were to get rid of this, the error would go away on both components, right? But the more important thing is that the CSS that is being applied is applied to that specific component. And so if so there's like a level of safety in the fact that the CSS is only applied to that component, and you don't have to worry about, if I get rid of this CSS, am I going to potentially blow up a component that is elsewhere? Like, it's very easy to have selectors with similar names, and now those classes are clashing with each other, and you're making a change, and it messes up. You could have hundreds of components, and it messes up components wherever, in all manner of places in your application. And so this just makes your CSS isolated to specific components. So now we have the idea of separating presentation logic and business logic. And before I continue, I want to talk about a little bit about what is presentation logic and business logic. And so presentation logic is pretty much any code that's primary function is to display something on screen. So HTML, CSS, native code, right? And business logic, its primary function is to facilitate a business function or rule. So imagine something like a shopping cart in an e-commerce application and adding items to that shopping cart. That would be business logic, right? So I am going to show you a quick example of what happens when you co-locate presentation logic and business logic. So this is the engineering sandbox. This is a personal project of mine where I just kind of mess around with front-end applications and ideas, but not even necessarily front-end applications, those are software development ideas. And so I made a component called Cute Animals component. It's calling the cat API. As you can see, I really like cats. Don't make fun of me, leave me alone, I like cats. So I made this component, and pretty much it calls the cat API, gets a bunch of images back, and then I apply that data to some markup that I have here. So the problem that this component currently presents is that I wanted to render this component in Storybook. And so for anybody who doesn't know what Storybook is a way of documenting your components. And it will just render components in like a sandbox environment. But it literally just renders the component, right? So it reads all of this JavaScript. It does not discriminate against the JavaScript that you have. And so it would run this fetch API. I should make quick mention that this fetch API is being declared elsewhere. But it would run this fetch API, right? And so imagine in a situation where you have you're making a fetch call to an endpoint that is in like a private network, right? And then you're deploying your Storybook instance to something that's public, or at the very least to something that is not, you cannot view, it wouldn't have access to the endpoint, right? So when you render this in Storybook, this component will blow up. And we don't necessarily want that. Like, obviously, this is not necessarily the case. The cat API is a third-party API that is public, but you don't necessarily want to run this logic, right? I should also mention that all of this that you see is really from React Query, which is managing the fetch call, right? And so I want to show you how I solve this problem. And it's pretty much by what we're talking about, which is separating the presentation logic and business logic. And so it wasn't particularly hard. I just moved the markup into its own component. So this is relatively same from what you saw previously, but now the markup is over here. Y'all can make fun of me for my props. I didn't spend that much time, properly, making sure that I'm passing things properly. I just kind of dumped everything into the presentation logic, but like at the very least, they're now separated, right? So here is the example of the presentation logic, and it's just mostly the markup. So we just take everything, we just pass everything through the props, and we leverage the data however we need, the data and supporting functions however we need. And so this is the actual story that I wrote from Storybook. And so because of that refactor, I was able to just mock out some data, and now I can render this in Storybook, and I don't need to rely on the cat API being up. Maybe it goes down, right? And I don't want my story to blow up. You know what I mean? So yeah, like that's pretty much it. So what are some of the benefits outside of that particular story that you get? So I mentioned better organization of files, because the cat API, the actual fetch call is being declared elsewhere, right? The code is easier to understand and reasonable. So the presentation logic is primarily just putting data on screen, and then business logic fulfills a business function. Like when you have them co-located, that component now has to do both of those jobs. With them separated, you can have a component or just a file that is doing that job and potentially have a single use case. And then all you're worrying about is successfully accomplishing that use case. And then again, presenting the data is same thing. All you're worrying about is how you're presenting the data. You're not even necessarily worried about where the data is coming from. It's also easier to build a more robust test suite. So when in the previous example, when we had the business logic and presentation logic co-located, if I wanted to test the business logic, what I would literally have to do is render the component, apply some action, through like test library, pray that that action has some effect on the component that I can look at and then test for that, right? Whereas in the when it's separated, I can just run that function, maybe just in vtest or jest. I don't have to actually render an entire component and then apply an action just to run that function. And then because I have access to that function, I can do more type testing, right? And then again, the presentation logic is easier to document, as the story I just told kind of shows, right? And so speaking of testing, we now come to kind of unit isolated testing, and which is pretty much writing tests to validate a single block of code or a function or something like that, right? And I just want to give you an example of what testing would look like. So it's just, this is a function from the engineering sandbox. This is just me, calling a database to get some data, and then this is just a quick test. I believe to test the shape of the data that I get back, right? And I don't want to get too much into how you do unit testing. There's a lot better resources than myself to teach you to do unit testing, especially in the front end. Kenzie Dodds has an excellent course, or excellent collection of courses, in fact, on how to do unit testing in the front end. But I want to talk about something specific. And I'm pretty sure there's people in the audience, maybe not so much here, but there's people in the audience who are maybe your front end engineers, was like, testing, I hate testing. I'm never writing tests ever. I just can't stand writing testing. I can't stand writing tests. And to be honest with you, I personally had an issue with writing tests as well. It was really difficult to do, right? And so I decided to write more tests, again for the engineering sandbox. And the reason for that was because I had a microservice that I wanted to split out into multiple microservices, and I wanted to just ensure that I could that it was working once I had done that split. And so I started writing a lot of tests for it. And as you write tests, as I was writing tests, I was noticing, this is not necessarily the best idea to do. This is not the best way of doing things. It's kind of difficult to try and test this stuff. And so I ended up changing the code base just to make it a little bit easier to test. And that kept happening over that period. Over a course of a couple of weeks, I wrote a bunch of tests, a bunch of tests. But that kept happening a lot. So I reached out to a TDD friend of mine, and I was asking, hey, can tests kind of like not necessarily affect your code base, but does tests kind of make you want to change your code base? And his kind of reaction was, yeah, it could kind of, but it didn't seem particularly, I wasn't particularly convinced. I kind of shrugged my shoulders and moved on. I eventually came across a talk, and the person in the talk said this: those tests, which they were referring to unit/isolated tests, put tremendous pressure on our designs. This is being said by J.B. Rainsberger, JBrains on the internet, during a talk called, what was it? It was called Integration Tests Are a Scam. I don't have an opinion on that. If you want to hear their opinion, feel free. Well, I mean, the name kind of says what their opinion is. But the most important thing is this is the thing that I was experiencing. And so this really validated like my experience, right? And so the reason why it validated my experience is because the way unit tests put pressure on our designs is through the feedback of writing the test, right? So I'll give you a quick example. So Again, this is from the engineering sandbox. This is me writing mocks for a function. It was a controller. Give me 1 second. Yes, so this was just me writing mocks for a controller. The orders, oh, actually not the controller, sorry, it's the model, right? And so I wrote some mocks for the test. Then I wrote more mocks. Then even more mocks. It's like it was just mocks everywhere, right? Like who would write a function that would require this much mocking to test? It clearly wasn't me, also known as the only author on the engineering sandbox. It wasn't me. You know, I'm a good developer, I promise. But like this is an example, right? So the feedback that this test was giving me was that maybe there was too many dependencies. Maybe you can do something about your design to reduce the amount of dependencies, right? Now, that feedback, you don't necessarily need to act on that. But the most important thing is that you recognize that you're getting that, right? That's the most important thing. And then interestingly enough, storybook stories apply the same type of pressure, right? Like I just told a story about, give me 1 second, please. Just my apologies. Remote work, you get knocks on the door. You just have to let people know that you're in a meeting. But yeah, so storybook stories apply a similar pressure, right? And where was I? I'm a little bit lost. Yes. So I just told a story about how I had to refactor. It was a small refactor, but I had to refactor my component to render in Storybook without an issue. And so this example here on the right is kind of describing the same mocking issue. To be fair, I didn't have to put this many images in the component. This is actually the same story that I showed you previously. And then another I'm pointing at it as you can see. Another example is like even the props, right? Like, so look at all of these like null, false, and so on and so forth. Like, again, this is feedback to say maybe I should change maybe how the props work, or maybe I should change how the things that I need to pass into this component. And again, to be fair, I don't need to have all of these images, but it's the most important thing is that it's giving me feedback directly on the design of this component, right? And that's what helps us continue to improve our designs for applications. So yeah, just quickly recap. We talked about atomic design, which is a component-driven design framework where we think of those components as atoms, molecules, and organisms, which build up to each other. Functional atomic CSS, which is pretty much smaller predefined CSS classes that are action-oriented and we apply directly to our components. Separating presentation and business logic, which is self-explanatory, and isolated and unit testing with isolated/unit testing and how those tests put pressure on our designs and give us feedback on them so that we can take that feedback and maybe improve our designs. So thank you so much for attending my talk, and feel free to go out and make your code bases an even more joy to work in. So I want to talk a little bit. I want to talk about the resources like for this talk. The Tech is Hiring Job Resources app is and the Engineering Sandbox, as I mentioned, are examples, are example apps for some of the concepts that I just talked about in this talk. So feel free to check them out. Just scan the QR code, and yeah, feel free to check out both of those repos. I also want to give some special thanks to Roselle and Carmen, who run a Twitch stream for speakers to practice their talks. A good portion of this talk was developed on that stream. I, in fact, came to that stream effectively with no talk, just some ideas. And I eventually gave that talk on that stream. And that's why this talk is the way it is today. And then Jeff, who is a staff engineer at Mozilla, I believe they work on the iOS Firefox app, really mentored me in putting together this talk. So I just wanted to give them a special shout out. So if you want to find me on the World Wide Internet, I tell this joke all the time and I laugh all the time at it. For anybody who doesn't know, the reference is what was it? Jones Barbecue Foot Massage. It's a really old video. Feel free to look it up and laugh your head off. But if you want to find me on the World Wide Internet, you can find me on Twitter at Chad_R_Stewart. Or linkedin.com/in/ChadRStewart. If you want to talk more about front-end architecture, or if you just want to find me and yell at me and say, everything that you said in this talk was terrible, how could you even give this talk? Feel free to reach out to me there. Can't promise I won't block you if you yell at me. And if you want to find out more about Tech is Hiring, you can check Twitter at Tech is Hiring or linkedin.com/company/Tech is Hiring. As you saw before, we recently released a job search resources app. Pretty much, if you're looking to do a job search in tech, you can go there and you can find resources to at least give you an idea how to start your job search, which includes job boards. Also, if you have a resource, if you've been on the job search before and you have a resource that you found really useful, you can submit that resource to the app. Please, please, please do so. You may help somebody else with their next job search. And yeah, that's me. Thank you so very much for attending the talk.